So the two types of magnets we've already done are ferromagnets. That's like a magnet that's made of a big chunk of iron. And that's the one that has like a material with the domains. These are the ones you're probably more familiar with. It's the ones that Bill Nye pretty much exclusively talked about in his video. These are things like a fridge magnet, a bar magnet, a horseshoe magnet, a compass. They're things where the magnetic field stays the same. It's called permanently, but stays the same unless you do something really drastic. Unless you shock it, drop it, heat it past 300 degrees Fahrenheit, these are going to stay the same magnetic field strength. Ooh, a thing that people were stuck on in the homework, if you've started the homework already, both the north and south side of a ferromagnet are going to attract other magnetic objects like paper clips. Right? One thing about magnets that's true is if you have something that has a magnetic field, like a ferromagnet, they always attract iron objects. Think about like your fridge magnets. No matter what direction you turn your fridge magnet, it never repels your fridge. It always attracts because your fridge magnet has its own field, and it always attracts neutral iron objects, like the fridge. Okay, other side of this, electromagnets. These are a lot more preferable than ferromagnets because they're adjustable. You technically get an electromagnet whenever you have a strong electric current. These are things like magnetic door locks, or the excavator magnet, or an MRI machine, or even the Earth itself. These are all electromagnets, and you can tell because the poles can change and move. The North Pole of the Earth, the North Pole of the Earth is actually in Antarctica, actually moves around pretty significantly year to year. It moves around pretty significantly because the currents inside the Earth, the currents of lava that are flowing around in big convection currents, those currents have electrons and therefore create fields. You can also check to see if something is an electromagnet, if you can turn it on and off. Magnetic door locks, excavator magnets, even speakers, like the speakers or headphones that you own, have an electric field that turns on and off. So a magnetic field that turns on and off. Yeah.
So why then would you say that they're more favorable than
Oh, I'm going to put that up right now. So they're more favorable because when you have a ferromagnet, it tends to be really expensive because they're heavy. So you have to ore all of this or mine it all out of the earth. It's heavy, so it's expensive to ship around. And this permanent thing is not super useful. Imagine if I tried to do like the magnet at the dump and I could get it to pick up iron, but I couldn't turn it off. Then I'd end up having to like try and remove all these big iron pieces from my magnet. Ferromagnets can't be turned on and off or reversed, so they're a lot less flexible. Electromagnets are cheaper and lighter because all I need is a current. Copper is lighter and cheaper than iron, and the current that runs through it can be turned on or off. If I put more current, I get more field. If I switch the direction of current, I switch the direction of field. So electromagnets are preferable because they're more flexible. The thing they have in common is the solenoid electromagnet, the one that looks like a coil and the one that you'll be doing your lab on, is going to have the same shaped field as the ferromagnet. So we'll worry, we've done the direction for those already. All we have to do now is come up with how to get its field. Okay. So there's going to be two forms of electromagnet, and this is going to be the first one. This is an electromagnet because it's using the electricity from the battery. to turn that coil of wire into a magnetic field. So a solenoid electromagnet has a coil of wire. Solenoid just is a fancy word for coil of wire. It has a certain number of coils, and it has a core. So you can kind of see that there's like a C thing going on here. There's currents and coils and core. There's going to be another one we'll add on later. Current, coils, and core. So the lab I'm going to send you to go do is going to look at the current, coils, and core of an electromagnet.